In this example, we're going to still take a look at the relation given by the equation y is equal to x squared minus 9. And we've already done parts A and B. Here's part B over here, the table and the graph. And in part C, we want to test this equation for symmetry. And so if this is symmetric about the y-axis, well then each point on the graph must have its reflection across the y-axis. So if xy is on the graph, then its reflection, namely the point minus xy, must also be on the graph. So symmetric about the y-axis means these 2 points must be on the graph. And this must be true for all values of x. So let's take a look at a couple. So here we have the point 3, 0, and its reflection minus 3, 0 is on the graph. The point 2, minus 5, its reflection is on the graph. And the point 1, minus 8 has its reflection minus 1, minus 8 on the graph as well. And so we see this is true for the points in red that we have plotted, but how do we check whether this is true for all points on this graph? So here, what we can do to check is substitute minus x in for x into the equation. So the equation was x squared minus 9. Y equals x squared minus 9. And so in place of x, I'm going to plug in minus x. And we evaluate. And what we get is y, when I square minus x, the negative squared gives me positive 1. So I get y is equal to x squared minus 1. And since we get the same equation back, an equivalent equation back, then we can see that this is symmetric about the y-axis. So we know it's symmetric about the y-axis. What about other symmetries? Is it symmetric about the x-axis or the origin? Let's go ahead and check those as well. And now let's check another type of symmetry. Let's see if the graph is symmetric about the x-axis. And an equation, its graph is going to be symmetric about the x-axis if the point for each point xy on the graph then the point, its reflection across now the x-axis must be on the graph. So when we reflect something across the x-axis, that means its x-coordinate stays the same and we get the opposite sign in the y-coordinate. So let's see if that holds for some of the points that we've got on our graph. So for example, we had the point 2, minus 5, which was on the graph. And so if it's symmetric, then its reflection across the x-axis should also be on the graph. And so let's check to see whether this holds. So here we were at the point 2, minus 5. Its reflection over the x-axis would be up here at 2, 5. And this is not a point on the graph. So this is not symmetric about the x-axis. Okay, and just this 1 point, 2 minus 5, shows that. So far we've shown that it is symmetric about the y-axis, but not symmetric about the x-axis. So what about the origin? Let's take a look at that one last. And finally, we can test to see whether this equation and its corresponding graph is symmetric about the origin. And the way that we check that is if the point, say xy, is on the graph, then its reflection across the origin, which means we reflect both across the x and the y-axis, then this point must be on the graph. So let's pick a point to check this out. So if, for example, (1 minus 8) is on the graph, but the reflection of this point across the origin, which would put us at minus 1, 8, is not. So therefore we see that this is not symmetric about the origin. Because this point over here doesn't have its reflection on the graph. So to summarize, this graph, this equation was symmetric about the y-axis, it was not symmetric about the x-axis, and it was not symmetric about the origin.